In this video, we're not going to think too much about programming, but I'm going to talk about something called currying, which underpins the way that Haskell works, or at least part of it. Now, currying is named after Haskell Curry, who Haskell, the programming language, is also named after. He's a famous logician, he contributed a vast amount to computer science, combinatorics, mathematics, and this action, currying, was named after him as well. So, what does that mean? Well, the first thing to start with is to think about functions. Now, we think about functions a little bit differently in Haskell than you might do at school. Remember, at school, when you were doing high school maths, you do get something like f brackets x comma y is equal to something. Now, that could be f x plus I comma y is equal to x times y. It could be a polynomial, it could be a differential equation, whatever it is. It's just you take these two arguments and then you return something else. And this would have the type here. This would take a tuple type of x and y's and it would return a z. Something like that would be fine in Haskell. Now, in Haskell, all functions are curried. And what does that mean? Well, you'll notice the type of Haskell, this is something like this. It takes an x and then another y and then it returns a z. But that's not quite the case because Haskell functions are curried. And what currying means is to take a function which takes multiple arguments and change it to something that only takes one argument. So this thing that takes an x, a y, and a z, and then returns a z is actually something that takes an x and then returns a function from y to z in Haskell. So all Haskell functions actually only take one argument at a time. Now this function, of course, has two arguments. It takes an x and a y to return a value, but step by step it actually takes an x and returns a function from y to z. And you might be thinking this is similar to partial application. Somewhat it is similar to partial application. It's not quite the same thing because this is generic to whatever the first argument of x is. When you partially apply something, you usually fix that first argument. But this is what currying does. So it means that in Haskell everything takes one argument and returns a function or output. So why would we care about this? Well, it might not be useful for your direct programming experience, but in computer science and pure maths and things like that, it's actually incredibly useful because you can analyze functions that take multiple arguments and by reducing them down to simpler functions which only take one argument. So you can prove things about things that take multiple arguments by reducing their complexity down via currying, which is quite a useful tool. Now, as I say, we won't be worrying about that too much in Haskell, but I'll just show you a little bit of an example of this. So for example, if we were using map, we might say something like, map takes a function times 2 and applies to the list 1 to 5. Now here, of course, we're actually applying both arguments at once. We're supplying both of the arguments. But the way that Haskell would reason about this is to say, okay, map, the function map, which takes one argument, took the times 2 function. And that returns another function, which then takes a list. So it's actually kind of, in your head, you could think of it as bracketing it like this. It's bracketing around the first argument and the function name. So if we get rid of this list here, and we call the type of this, you see that this is now a function from B, our list of B's, to B's. And that's similar to what we had up here. Now, of course, if we take this name here, and then we apply it, we'll just get what we would expect. So we'll get the numbers 1 to 5 multiplied by 2. So that's simple. Now in Haskell you can uncurry things if you want. Everything is curried, but that doesn't stop you from uncurrying it. And you can just call the uncurry function for that. So if we say uncurry map, you can see here we get something more like the tuple that we would expect from our Haskell math notation. So this is saying that map takes a function from A to B as its first argument, and then it takes a list of A's and returns a B. So the fact that everything is curried in Haskell is not to say that Haskell cannot handle functions that take multiple arguments. This is just Haskell's way of managing these more complex arguments. Of course, in Haskell you can as well curry things. So we could curry the uncurried version of map, and if you're quick on the draw, you would expect that this would be exactly the same thing as map, because currying and uncurrying things should return the identity, it should return what you started with originally, and of course we do get the map function back. So this is what currying is. Currying takes a function that takes multiple parameters and changes that to a function which takes one parameter, returning a function. So this is just something to broaden your understanding of Haskell, deepen your knowledge a little bit. As I say, this is not something that you won't necessarily need to know this to program. but it will help to broaden your experience with Haskell, understand a little bit more of what's going on underneath the hood it was, and broaden your understanding of more theoretical computer science in general. So that's everything for today. If you have any questions about this, please do feel free to get in touch. Thanks.